Hello everyone. Today we're going to learn our chapter 4. So, chapter 4 is about class diagram. So, what it is class diagram? Class diagram is how you create the process based on the component that involved in your system. So, let's see here. This is the modeling notations. Okay, in this in here you see all the different kind of modeling notation based on the UML. Okay, so first, the UML class diagram. The UML class diagram is actually contain the information structure relationship between data item, and it also contains the modular structure for the system. As you can see, there's like some boxes there with arrows, so it shows the relationship between data items in your system. Okay, moving on to UML package diagram. So UML package diagram contains the overall architecture, and it also shows the dependencies between components. And then UML sequence diagram, which actually it shows the individual scenario, and it also shows the interaction between users and system and the sequence of messages. For example, what kind of message that user will send to the admin, and then how admin responds back. And then use case. In use case, you will show the user's view, and then list of function for users, and then it also shows the visual overview of the main requirement of the system. And then the UML state chart, it contains response to events, and also it shows the dynamic behavior, the events ordering, reachability, and deadlocks of the overall system, how the system process. And then last one is the activity diagram. It contains the business process, the concurrency, and the synchronization, and then it also shows the dependencies between tasks. So these are all modeling notations. Okay, so in this chapter what you will learn further details on how are you going to design this this class diagram, okay, based on the cases. All right, so let's move on. So normally when you start designing class diagram is at the design phase. Okay, so actually what did you do during design phase? You specify the structure of how a software system will be written and function. So you don't have to write the complete implementation, the program, but what you have to do, you have to know what classes will we need to implement a system that meet the requirement, and then what fields and method will each class have, and how will the class interact with each other. All these details you have to do in design phase, and this is when the UML diagram, the class diagram, will be really useful. And now let's start. Okay, actually what is UML? UML is a short form for Unified Modeling Language. So in UML, it will show the big pictures of an OO system. And then it will in UML, you don't have to decide what programming language you're going to do yet. All you need to do is you have to know the process, the component, okay, the component in your system. So why we need this? Because the programming language are not abstract enough for the design, okay, and UML is an open standard. Okay, so actually what is the UML? the definition. Okay, it is a picture of a classes in OO systems. There are fields and methods and connections between the classes that interact or inherit from each other. So that means like the previous slide when I showed the UML notations, how the component and how the flow when you design UML, you will know the process involved, the component involved in the systems. Okay, so what is actually things that we don't represent in UML? Normally, we don't show in UML the details. Okay, details like every single thing like we do in our code, we don't show. We just show the rough idea of how the system going to work. And then we also didn't show the algorithmic details in your UML. So, what actually the function of UML? So, UML normally we use as a sketch, okay, as a sketch to show how the aspect of the system communicate. Okay, so you can design your UML two ways. Okay, it's either forward design or backward design. Okay, how forward design? Forward design is you do your UML first, you sketch UML first before coding. For backward design, you sketch the UML after coding, which is you keep the UML sketch as the documentation. Alright. So normally when people sketch UML, they normally done on whiteboard or papers, and it's normally used to get the rough selective ideas of the flow of the system. And other than that, some designer also use UML as a blueprint. Okay, when they use UML as the blueprint, they show the complete design, how the system going to be implemented. All right, and then on the other hand, you can also use UML as a programming language. How? Because there are a lot of tools out there that you can use to sketch the UML diagram. Okay, some of these tools, when you finish sketching the UML diagram, you can actually convert it into into a code. So the code will be auto-generated based on the UML that you sketch on that particular tools. So normally it is fast to do this, but sometimes it's not as easy as that. It depends. It depends on how you design your UML. So now we want to know how to start using UML, how to start sketching UML. So first you have to know the class, okay, the class that you are going to use in your system. All right, so in designing UML, class will describe a group of objects with similar properties, common behaviors, common relationship to other objects, and also common meaning. So this is the how the diagram of class gonna look like. So in the class name will be on top of the box. For example, here you can see the class name here is employee. So when you write it, you must use italic for an abstract class name. And then in the second box, you should include the attributes or the fields. So in this box, it should include all fields of the objects. For example, here, name, employee numbers, and the department. And then on the third box, it should include the operations or the methods. Okay, for example, here, methods for this specific class name is hire, fire, and assign project. So it depends on your system, on the component, the classes, the objects that you include in your system. So that's how you are going to sketch your own class diagram. So when you are trying to write the class attributes, which is in the second box, you have to show the visibility of the component in your box. For example, you have to know the plus signs is for the public, and then hash signs is for protected, and the star signs is for private, and the minus signs is the package default. And if you underline your component in this box, it means it's a static attributes. And for class operations, it's also the same. And then here it will also shows the format, visibility, names, and then it will also shows if it is return type parameters. Okay, for the visibility symbol is also the same with the class attributes. For public, protected, private, and package. I think I made a mistake earlier. Private is not a star symbol. Private is a dash symbol, and package is like a volume symbol. If you can see in your slides for a better view. Okay, it's also the same for static method. You have to underline, and then the parameter types also different. And then this is the full class notation. Okay, as we learned earlier, the name of class should be on top, and then the class attributes in the middle. At the bottom is the operations. As you can see here, this is the full class notation for class name students, and it shows here what is the attribute name, the visibility, and then also the default value. And then in the operation class, it also shows the operation name, the parameter, and the return value. So this is the same example of one class, how you sketch the class diagram for one class, for student class. Okay, so and then you have to know when you're sketching the class diagram, you have to know the relationship between classes. Okay, so when you start sketching, there's classes do not exist in isolation from one another. Okay, you have to show the relationship that represent the connections among teams. Okay, among things. So if you have three classes for your system, for your project, you have to show all three classes in your class diagram. For example, if you have an employee class is associated with the person class. You have to show this in your class diagram. And in UML, there are different types of relationship. Okay, there's association, aggregation and composition, dependency, and generalization. So now we are going to go through all of that. So first, the association. Association, it represents a general binary relationship that describes an activity between two classes. Okay, you can see here the student and faculty class is connected with the course class. Okay, it connected with course. So in association, it's usually represent the data field in the class. So you can see here, student take course and faculty teach course. Who teach the course? The teacher teach the course. So in the association, there are several types. There are aggregations, compositions, and dependencies. Aggregation means is a part of, is symbolized by a clear white diamond. You can see on the right side here, engine is part of the car. It shows the clear white diamond symbol. That means the aggregations. And the composition. Composition, it means the entirely made of. It is a stronger version of aggregations. And then the part live and die with the whole. And it is symbolized by the black diamond. So here in the example here, you see page is entirely made of book. So that means there will be no book if there's no page. So that means it really depends on each other. And then last one is the dependency. Dependency is used temporarily. It's symbolized by the dotted line. So you can see here, book used temporarily shelf. That means the book can be anywhere. Okay, it will be on that temporary on that, for example, there's book A and shelf 1. So book A will be on shelf 1. It's not forever. If somebody borrow it, it will not be on shelf 1. So that means it used temporarily. Okay, so that's why it shows there, often in an implementation detail, not an intrinsic part of the object space. So that's how the dependency, composition, and aggregation works. This all is type of association. Okay, this is another example. Okay, so in this example, we want to show a person works for a company. So there will be two components here, person and company. And then in the middle, it shows the connection, the relationship between person and company. So it shows here the person works for company. Works for, here it shows the association name. And then association may exist between objects of the same class. For example, here it shows a person may have a supervisor. So that means the supervisor is also employee, but supervisor also included in the person class. So we have to show the relationship between the person and the supervisor. And when you're creating a class, you also have to consider the multiplicity. Okay, the multiplicity, it shows the connection uh, between the class. Okay, there's one-to-one relationship, one-to-many, one-to-one or more, etc. Okay, we will go further. So in multiplicity, it can be expressed as a number. Okay, if the relationship means exactly 1, you write number 1. If 0 to 1, 0 dot dot 1. If 0 to many, it shows many relationship. 1 or more, you write 1 dot dot star. If the exact number, for example 3 to 4 or 6, if it's a complex relationship, for example 0 to 1, 3 to 4, 6 to many, would mean any number objects other than 2 or 5. That's how you show the complex relationship. And for aggregation and composition, so for aggregation is a special form of association. So it shows the ownership relationship. It also models that has a relationship. So as we learned earlier, aggregation with the symbol of white diamond, right? So in this example, address has a, that means the person has the address. It shows the aggregation relationship. And then the composition. Composition is a special form of aggregation. That means the object exclusively owned by the aggregated name. So name is exclusively owned by this person. So to show composition is using the black diamond symbols. So this is the difference between composition and aggregation. And for the dependency relationship, it shows the relationship between two classes where one we call as client and the other one we call as the supplier. So in UML, we draw a dashed line with an arrow from the client class to the supplier class. So as the example here, it shows the dependency from the course set schedule to the course. That means the course exists because course is used in both add and remove operation in the course schedule. So that is how you show the dependency. Okay. So the dependency versus association. Normally association is stronger than dependency. And also in association, the state of the object change when the associated object change. So that means if you change the object, this the association relationship of the object also change. So in dependency, the client object and then the supplier object are loosely coupled. It don't really depend on each other. So when you try to implement in programming, normally association is implemented using data field and method. Okay, there are strong connection between two classes. All right. So and dependency is normally you implemented using methods in the programming. So coupling is actually, it shows the relationship between two classes. So it shows the when the coupling increase, it will increase starting from dependency and then association and then aggregation and then composition. So composition is the strongest relationship between two classes. Okay, that's how it shows the flow. All right, for generalization. Okay, generalization is a models the is an extension of relationship between two classes. So it's like a relationship. So it's normally hierarchical relationship. It can be draw top down with arrows pointing upwards to the parents. All right. So the class will be a solid line, white arrow. For abstract class, it will be solid line, white arrow. And then for interface, you have to use dash line, white arrow. So it depends on the type of class, how you create, how you sketch the generalization relationship in your class diagram. So let's see at the example of the generalization relationship. So it connects the subclass. The subclass here is the students and the superclass. The superclass is person. So it shows that the inheritance of attributes and behavior. That means the student class will inherit the attribute and behavior from the superclass. Okay, whatever superclass has, which is the person class, it will be inherited to the student class. So now we are going to look at the example. So in this example questions, we have to draw a class diagram for an information modeling system for a school. So school has one or more department. Department offers one or more subjects. A particular subject will be offered by only one department, and department have instructors, and instructors can work for one or more department, and students can enroll up to 5 subjects in school. Instructors can teach up to 3 subjects, and then the same subject can be taught by different instructors, and students can be enrolled in more than one school. So this is the situation. Okay, given this situation, given this uh, sentences, what we have to do, we have to think, okay, now we have the statement, we have the situation. Okay, from here we have to know how many class will be involved. Okay, as we see here, there will be school class, department class, subject class. Okay, so and then we have to know, okay, how of these classes will interact. Okay, what is the relationship between class. Okay, we have to know how schools, what is the relationship between schools and class. Okay, here is how we sketch one by one. Okay, now we want to see school. Okay, school has one to many departments. So it shows that school has one or more department, the statement earlier, right? And the department offers one or more subjects. So department offers one to star. That means one to many relationship, right? We learned earlier in the multiplicity, one to many subjects. So a particular subject will be offered by only one department. Alright, so this is how you sketch it. Alright, so moving on. So now move to the second statement, which is department has instructors, and instructors can work for one or more department. I'm sorry for the color of the font. I forgot to change the color. So the instructor assigned to department, that means the instructor can be assigned to many departments, so one to many relationship. And students takes subjects, that means student can take up to 5 subjects, right? So the relationship, the multiplicity for subject here is exact, is 0 to 5. It cannot be more than 5, so you have to write 0 to 5 multiplicity for this particular class. And then another statement, the instructor can teach up to 3 subjects. The same subject can be taught by different instructor. So it's the relationship between instructor and subject. So instructor teach subject. So how many instructors? It can be a lot of instructors, right? So one to many, multiplicity. And then each instructor can only teach up to 3 subjects. So 1 to 3 multiplicity for subject. So now the relationship between student and school. The statement is student can be enrolled in more than one school. So student, member, school. The multiplicity here is one to many. So this is how the overall class diagram gonna look like. So you sketch each relationship, right? And then you combine all the classes, all component into one big um, picture. So now you can see the relationship of each component. Here you have student, we have school, we have department, we have subject, and then we have instructor, and then how each component is connected to each other. So we also have object diagram. So object diagram shows the relationship between objects, and then it also have a state. The class diagram earlier doesn't have a state, right? So this is the example of the object diagram. So it shows here the subclass. We have person, department as is the subclass, and the company is the superclass. So there will be two departments, and then the person, there will be two kind of subclass here, the manager and the employee. So in object diagram, it shows the state. That means it shows, okay, the department, what is the name of the department, and then the person, the detail of the class for the person, the name, like earlier I shows in the earlier of the slides, the name, the company name, the company number. So actually, in this chapter, what we have learned is how we design the classes, how we design the the system by knowing the function, the relationship of each classes before you even start with developing it first.